Dear students, welcome to the lecture series on the topic Engineering Graphics. So today we are going to discuss about projections of the oblique solids. I am Dr. IPS Ahuja, Professor, Department of Mechanical Engineering, Punjabi University, Patiala. So an oblique solid is the one which is inclined to both the reference planes, that is horizontal plane as well as the vertical plane. So let us first of all evaluate the order of inclination of this right circular cone with respect to the horizontal plane and the vertical plane. So we are required to draw the projections of a right circular cone having base diameter equal to 50 millimeter, axis height is equal to 65 millimeter, which is resting on horizontal plane on a point of its base circle with axis making an angle of 30 degree with the horizontal plane and 45 degree with the vertical plane. So here we need to remember one thing, that the true length of the axis is inclined at an angle of 30 degree with respect to horizontal plane initially, and then the same true length is inclined with respect to vertical plane at an angle of 45 degree. That is, in both the cases the true length of the axis is inclined at an angle of 30 degree to HP and then 45 degree to the vertical plane. So this angle of 45 degree which is provided to us, this is the angle phi. Now the second thing, since this cone is resting on horizontal plane on a point of its base circle, so we are going to assume that initially this cone is resting on the horizontal plane on its base over there. So this is the base of the cone. So this is going to rest on the horizontal plane, and since the first angle of inclination of this cone is with respect to the horizontal plane, so therefore we are going to draw the top view of this cone, that is this one, onto the horizontal plane, that is the true shape of the circular base will be drawn onto the horizontal plane in the top view. So obviously this will be drawn below the XY reference line. So this is another thing. Then one thing we need to keep in mind, that whether we want to divide this cone into 8 equal parts or 12 equal parts. If we divide this cone into 8 equal parts, so the angle which will be separating any two generators will be 45 degree. If we are going to divide this cone into 12 equal parts, so the angle which will be separating any two generators over there, this will be 30 degree. Another thing we need to remember specifically in the case of a cone which makes cone different from the other solids, that is, which are prisms and the pyramids. In case of prism and pyramid, whenever a prism or a pyramid is resting onto the ground and it is inclined with respect to the HP, we work out the farthest most point over there. If the observer is looking from here, we work out the farthest most point, and then next 2 points which are edges which are going to join this point, they are drawn dotted over here. That is, the point which is farthest away from the observer will be affecting 2 edges over there which will be next to it onto the base. Whereas in case of the cone, the difference lies here, that whenever you see this is a cone, if I incline it this way or if I incline it this way, if I incline it this way, it will be resting on this corner. So what will happen? It is resting on this corner of its base on the horizontal plane. But here, even though this point is the farthest point from the observer, so these two things, they will not be dotted. What will happen? You see, whenever a cone is inclined, this uppermost semicircle, so this is going to be visible to the observer, and this projected portion of this cone, that is the semicircular portion of this cone, this is going to overshadow the bottom portion of this particular cone. So this bottom semicircular portion of the cone will be overshadowed by the uppermost semicircular portion of the cone. So whenever a circular plate, basically it is nothing but a circular surface. So whenever a circular surface is inclined to any plane, its projection on that plane will be an ellipse over there. So onto an ellipse, the point which are corresponding to this uppermost portion of the circular cone, these will be drawn dark, that is using the object line, whereas the points which are appearing onto the ellipse which correspond to the bottom portion of this cone, they will be drawn dotted. So here half of the ellipse, that is the innermost part of the ellipse, will be drawn dotted, whereas the outermost part of the ellipse which is visible to the observer will be drawn dark. So this is how cone is different from your other solids, that is your pyramids or your prisms over there. So let us start working out the projections of this cone. Now initially, as we have discussed, the cone is resting on the horizontal plane on its base. So the top view of the base will be drawn and it is having the diameter equal to 50 millimeter. Now we are going to divide this into 8 equal parts so that the included angle between different generators will be 45 degree. So every generator will be 45 degree apiece. And having drawn all the, now we are going to join all the diagonals. So wherever all these diagonals join, we are going to get the location of the axis point. So two axis point, they have been located, O and 1. You see, O is the apex point for the axis, 1 it is the bottom point for the axis over here. Similarly, you see 8 points we have listed over there, A, B, C, D, E, F, G, H. So this completes our top view projection of the cone. So let us now start working out the front view projections. So since this base of the cone is lying on the horizontal plane and it happens to be perpendicular to the vertical plane, so the front view projections from A, B, C, D, E, F, G, H, they will all be lying on the horizontal plane, that is on the XY reference line. So the front view projections will be A dash will be appearing here, B dash and H dash, they will be appearing here. Similarly, C dash, G dash, they will be appearing here corresponding to the base. Similarly, D dash and F dash, they are appearing here on the XY line. Similarly, E dash is appearing here right now. Now we know the axis height is equal to 65 millimeter, and having worked out the 65 millimeter axis height, point O dash on the axis has been located. So point O dash will be located, and once you locate point O dash over here and 1 dash on the base, now next we are going to join all the generators or the slant edges of this particular cone. So these are the artificial generator. You see the interior generators, they are the artificial one. The outermost generator, that is O dash, A dash, this defines the boundary of the cone. So this is my dark line projector, object line projector. Similarly, O dash, E dash, this is the boundary line projector. So this is drawn dark, and interior generators, they are drawn with the help of 2H. So this completes our front view elevation of the cone which is resting onto the ground. Now we are provided with the fact that this cone is resting on horizontal plane on a point of its base circle with axis making an angle of 30 degree with respect to HP. Now you see, since the axis is making an angle of 30 degree with respect to the horizontal plane, so we are required to shift this figure, this entire triangular shape front view, we are required to shift at an angle of 30 degree with respect to the axis over there. But since if we start doing that, then we have to make sure that point E dash will be lying onto the ground. So that would be little bit difficult. So what we usually do, whenever the axis angle of inclination is given to us, so rather than taking the axis angle of inclination straight away, we assume that the base of this particular image, it is inclined at an angle of 90 degree minus the axis angle. So 90 degree minus 30 degree means 60 degree. So to begin with, you see, we are going to shift this figure number 2 to figure number 3, that is rotation or translation will be done such that it will be shifted in this orientation, so that the cone will be resting on the point E dash of its base onto the horizontal plane. Now let us see how we have gone about shifting of this figure from this location to this location. So point E1 is fixed. We'll draw the angle of 60 degree. So 60-degree projector will be drawn through point E over here. Once we draw the projector through E1 dash at an angle of 60 degree, now you see we are going to mark these 5 points. Point number 1 E dash, point number 2 F dash D dash, point number 3 1 dash G dash C dash, point number 4 H dash B dash, and point number 5 A dash. So these 5 points we are going to mark. The moment these 5 points over here, so E1 dash is located automatically, F1 dash D1 dash is located, G1 dash C1 dash and 1 dash is also located, H1 dash B1 dash is located here, and similarly A1 dash is located. Now since we always use the rectilinear distances, so this point will also be located using rectilinear distances. That is from point 3, you can check, this is my point 3. From point 3 I am going to draw a vertical projector which will be equal to the axis length of 65 millimeter. So axis height or axis length is 65 mm. So from here I will be drawing the axis height or axis length equal to 65 mm. Point O1 dash will also be located. So having located this, now I can join O1 dash with A1 dash, that is the object line. O1 dash will be joined with E1 dash, again object line, because these two corners, edges, they define the boundary of the cone. And 3 interior diagonals, they will be joined, interior generators, they will be joined using 2H lines over there. Now once we extend this axis line, now you can see axis, since the base is inclined at an angle of 60 degree, this is the right circular cone. So right circular cone means axis of the cone is at an angle of 90 degree with respect to the base. So this angle is 90 degree. This angle we have drawn as 60 degree. So automatically this angle is 30 degree. So since this is the angle which was given to us, so we can see that the true length of the axis is inclined at an angle of 30 degree with respect to the horizontal plane. Now this was not given to us, so I am going to take this out. Please check this. I am going to take this out. So this will be rubbed. Now there is no proof that I have tilted it with respect to base at an angle of 60 degree, right? So this is only to facilitate one thing, that always whenever I am shifting with respect to base, I am ensuring that my point or the corner or the edge, it will be planted onto the horizontal plane or on the XY line. Otherwise, if I tilt it with respect to this 30 degree, then I'll have to manage this height so that this corner should be resting on the XY line. So that will make my job tedious. So better is you shift it with respect to the base and then remove this angle. Now we have to draw the top view of this particular cone over here into the first iteration. So in order to obtain the top view, what we are going to do, fourth view is always corresponding view. So corresponding points we are going to obtain. So how many points are there? Please check. 8 points corresponding to the base, 2 points corresponding to the axis, 10 points are there. So from all the 10 points of the previous plan projection view, draw the horizontal projector lines, and for all the 10 points from the current elevation view, draw the vertical projector lines. And wherever these corresponding projector lines, they intersect with each other, we obtain the points A1 dash, A1, B1, C1, D1, E1, G1, H1 over here. Similarly, O1 and 1 will be obtained over here corresponding to the axis. So let us start locating those points. So here you see we have located these points, and let us see how we have obtained these points. So you draw the vertical projector from A1 dash till it intersects with horizontal projector through A. So this gives us A1. Similarly, draw the vertical projector through B1 dash and draw the horizontal projector through B. So wherever these two projectors intersect, you get B1. Similarly, through C1 dash, draw the vertical projector. Through C, you draw the horizontal projector. Intersection gives you point C1. Through D1 dash, again draw the vertical projector. Through D, you draw the horizontal projector. Intersection gives you D1. Through E1 dash, draw the vertical projector. Through E, you draw the horizontal projector. Intersection gives you E1. F1 dash, draw the vertical projector. Through F, draw the horizontal projector. You get the point F1. through G1 dash, again you draw the vertical projector, through G get the horizontal projector, intersection will give you G1. Similarly, point H1 has been located through drawing vertical projection through your point H1 dash and then drawing horizontal projector from H. So intersection provided us with the value of location of H1 point. Now these points are located. Now once I am going to join this ellipse, please see, this is a circular shape. So any circular shape, when it is inclined to a surface, its projection on that surface will be an elliptical shape. So we have been able to obtain ellipse. This has to be joined freehand. So this ellipse has to be joined freehand, but please see, I have not joined this fully dark all over the place. Why? Because this thing we have already discussed. Please see, since we are looking from the top, so the observer will be able to see this semicircular portion only. So this semicircular portion will be visible to the observer. So which is this semicircular portion? See, C1, G1, B1, H1, A1. This is the uppermost semicircular portion which will be visible, and this semicircular portion will be overshadowing the lower semicircular portion which has been hidden by this particular projection of the upper semicircular projection over here. So this semicircular portion will be hidden by this particular surface over there because of the incline, which is quite you see apparent from here. This is visible, whereas this portion is not visible. So this is an opaque solid. So since this is an opaque solid, projections corresponding to all the points which are lying within this case, so that is on the interior side, whatever points they are lying, they will be drawn dotted over here. So this is the significance. And then please see, again I am going to show you through this. So since the observer is going to look at this particular solid from the top, please check, this portion will be visible, right? Please check, this portion will be visible to the observer, whereas this portion, it has been covered by the projection of this portion of the cone over there. So the upper semicircular portion is visible, the lower semicircular portion which corresponds to see EFD, just see, which corresponds to EFD, that is not visible to the observer. So that is why the interiormost portion of this will be dotted. It is not that since we are looking from the top and E1 dash is the farthest point, so corresponding to E1 and F1 and D1, only this portion is not dotted. It is not partial semicircle, it is this complete semicircle which is not visible on the lower portion over there. So this is the upper portion which will be visible starting from C to G, and this is lower portion starting from C to G but covering the points D, E and F. D, E and F, these points, they will be covered. So this entire semicircle will be dotted. So that is why the simple fundamental which was used in ellipse in the case of prisms and pyramids, that is not applicable in the case of cone. In case of cone, half of the semicircular portion will be visible, remaining half will be dotted. It's not that since this is the farthest point, so only this semicircular portion should be dotted. No, it is the entire semicircular portion which will be dotted over here. That is why I have shown it separately with the help of a bigger model over there. Then having drawn this ellipse, now I have got the point O1. From O1 I am going to draw tangent towards G1, and from O1 I am going to draw tangent towards point C1 over here. Next, now another thing is observed, that is the true length of the axis was O1 dash 1 1 dash, whereas it is inclined to the horizontal plane, so its projection on the horizontal plane is O1 and 1 1. So this is the apparent length of the axis, but we have been provided with the fact that the true length of the axis is inclined at an angle of 45 degree with VP. So it is not the angle beta, it is the angle phi. So now using principles of rotation of the line, we are going to evaluate angle beta, and then having evaluate angle beta, So this figure will be rotated at an angle of beta with respect to the vertical plane. So let us try to work out angle beta. So please check. This is my axis of the cone, that is apparent length or the plan. So this is the axis top view length, which is the apparent length. So now again two situations I am going to discuss. In the first situation, I will assume that this apex is resting over here and the cone will be drawn here. In the second situation, I will be assuming apex is resting here and the cone is drawn over here. The base of the cone will be drawn over here. So how do we obtain both the projections in both these cases, right? So first of all, apex point has been located O1. Then the second point of the true length is this one, you see 1 1. So how much is the height of this axis? 65 millimeter. So I am, because the angle is given to me as 45 degree for the true length of the axis to be rotated. So the true length of the axis is inclined, which happens to be 65 millimeter at an angle of 45 degree. That is why this angle is given to me as angle phi. So this is the true length of the axis, 65 millimeter. Now the first point is O2. Second point will be O21. This point's name will be 1, 2, 1. This is 1, this is 2, and then 1 suffix is always there besides any given true length. So this true length is equal to 65 millimeter. Now one locus line has been drawn. Another locus line I am going to draw here, because using rotation of line, I understand that the true length and its angle, if they are known, I can draw the true length. And once the two projectors of the true length they have been drawn, if I am going to have either the beta angle, then the apparent length will be worked out. If I am going to have the apparent length, then angle beta will be worked out. Two situations are there. True length and true angle are there. I have drawn this line. So two projectors, horizontal projectors, they have been marked over here. Now if the true angle beta was available, I would have drawn that and apparent length would have been calculated. But over here O111 is available. So here it would be O212. So I know this length. You see, this is my length which has been shown over here. So I am going to transfer this apparent length of the axis over here. So the moment I transfer, you see, it is the same arrow which I had drawn over here. So same arrow I have drawn over here. So this arrow is O212. That is, it is the locus of center of 1. So this point name is 1, 2. And this angle will become angle beta. So automatically I have calculated angle beta. And we know from the fundamentals of the rotation of line, apparent angles, they are greater than the true angle. So apparent angle beta is greater than the true angle. So angle beta works out to be equal to 51 millimeter. And apparent length is smaller than the true length. You see, this is true length of the axis, which is bigger. This is apparent length of the axis, which has been picked up from here. So having drawn the apparent length, having measured the apparent angle over here, now this figure will be transferred. Please see, this figure will be transferred at an angle of 51 degree, not at an angle of 45 degree. Why? Because 45 degree was the angle of inclination of the true length of the axis with the vertical plane. So we have to transfer only this figure. So this figure has got apparent length. So I need to work out the orientation of the apparent length with respect to the vertical plane, which I have done using the fundamentals of the rotation of the line. So angle beta has been worked out to be equal to 51 millimeter. Now you see, this figure has been transferred here using rectilinear distances. So please see what I have done. Step number 1, I have transferred this axis and then drawn a locus line perpendicular to the axis line. You see, this is my axis line. I have drawn a locus line which is perpendicular to the axis line. Please check. This is my axis line. This is my perpendicular to the axis locus line. Now from this line, I'll again start marking the points. Point 1 is G1, point 2, point 3, point 4, point 5. From point 1, 3 and 5, I will get G1, 1, 1 and C1 at 0 distance. Please see, from point 1, 3 and C1, the fifth I get these 3 points G1, 1, 1 and C1. Just see from here 1, 2, G2 and C2 at 0 distance they have been located. Then from point 2 and point 4, just see point 2 and from point 4, I'll draw this vertical distance. I'll measure only one distance. This is equal to this. Similarly, this is equal to this and this is equal to this. So one distance you measure, so automatically 4 distances they will be available from points 2 and point 4. So those vertical distances are plotted. So F2, H2, D2, B2 they have been located. And from point 3 you measure distance of E1 which is equal to distance of A1. So from point 3 measure distance of E1 which is equal to distance of A1. So this way E2 and A2 they are also generated. So now this plan projection which was obtained in step number 4 has been rotated and translated at an angle of beta is equal to 51 degree. Now we have to obtain the front view. So once again corresponding points we are going to work out. So vertical projectors we have to draw from here. Horizontal projectors will be drawing from the previous elevation view. But before we proceed, this line was not dotted because this picture and this picture should be the same. So please check, no dotted lines were there. So let us carry out the hidden line procedure. So I have carried out the hidden line procedure, that is these lines have been cut appropriately so that this portion is hidden and this portion is solid. Right now this picture, this figure and this figure they are identical, only difference is now the axis is inclined at an angle of 45 and the plan of the axis is inclined over here at an angle of 51 degree which is equal to beta. Now let's work out the front view points. So in order to work out front view, take the vertical projectors up. Similarly take the horizontal projectors from left to right and find out once again the corresponding points. So you see all these corresponding points they have been obtained. Now O2 dash, one vertical, one horizontal. Similarly all these points they have been worked out. Now the question arises, if you are looking from this side, please see, if you are looking from this side, which points will be dotted and which points will be dark. So again, before we start working out those things, let us work out first of all the point. So this is the projector for A2. Take vertical projector, horizontal projector through A1 dash. This gives us A2. This is projector of B2. Take it vertically upwards. Take horizontal projector from B1 dash. You get B2 dash. Projector from C2. Take vertical projector. Take horizontal projector from C1 dash. You get C2 dash over here. From D2, take the vertical projectors up and from D1 dash, draw the horizontal projector. You will get D2 projector over here. From E2, take the vertical projector up. So it lies on E1 dash. Draw the horizontal projector. You get point E2 dash over here. Similarly, F, you take vertical projector through F. Wherever it intersects with the horizontal projector through F1 dash, you get F2 dash. Similarly from G, this is G point, G2, take vertical projector up, draw horizontal projector through G1 dash, you get G2 dash. Finally H2 is this, that is this is your H point, you take it up, wherever it intersects with the H1 dash, so this will give you the H2 dash. Now if you are looking from this point, please see, if you are looking from this particular position, whole of this cone, because the observer is facing this circular base, so observer will be able to clearly see the circular portion of the cone. Now which is the farthest point? Farthest point is O. So this I have drawn dark. Please see, this I have drawn completely dark because this circular base of the cone is facing the observer. So observer will be able to see all these points. Now which is the farthest point? Farthest point is O2. So let us join O2 dash. From O2 dash draw tangent onto F2 dash. From O2 draw tangent up to the point B2 dash. But what is this? I have drawn these dark. Why dark? I have drawn these dark because I have to satisfy this condition. Any points joining O2 dash will be dotted unless they are forming the boundary of the object. So please see, O2 dash and F2 dash, they are forming the boundary of the cone. O2 dash and A2 dash or B2 dash again that is forming the boundary of the cone. So had there been some internal parts, internal projectors which were not forming the boundary, those projectors would have become dotted over here. So any point joining O2 dash would be dotted unless that particular edge becomes the outermost part of the boundary of the solid. So O2 dash, F2 dash forms the boundary. So it has to be drawn dark, even though O2 is the farthest point from the observer and O2 is a point which is closest to the XY reference line. So O2 dash, F2 dash will be dark, O2 dash, B2 dash, this will also be dark. So no hidden line in this particular case. Let us work out the other case when your apex is facing over here. Now please see, axis also has been joined. So this is the axis which has been joined over here. Now let us work this out other way around. That is, apex lies here and your cone base lies here. So what would have happened in that case? So once again, using rotation of line, we have to work out angle beta in the similar way as it was done in the first case. So angle phi of 45 degree we have drawn. True length of the axis will be inclined at an angle of 45 degree. So this is 1, 3. So point 1 is located because circle will be drawn, ellipse will be drawn over here. Apex is facing the observer. So the apex point will be lying here. So name of this point is, you see, this was O1. So this is O2. This will be O3. But had it been apparent length, its name would have been O3. But since it is true length of the axis, so the name of this point will be O31. Name of this point will be, please check, O31. Why? Because this is the true length of the axis. So once again, you see, I have done the marking. So this length I3 or 1, 3 to O31. This is the true length which is equal to 65 millimeter. So this is 65 mm. Now two locus lines will be drawn. I know the apparent length which is equal to O111. It is this arrow. So this arrow I am going to draw again corresponding to the apparent length. And having worked out the apparent length, O3 will be worked out over here. So point 3, O3 will be there. This is the apparent length. The moment I get the apparent length, angle beta I can measure. Please see, angle beta becomes apparent, which is equal to, once again, 51 degree. And there will be no difference in the angle beta in this case or in this case. Now let us change the orientation. This point's name is O3. So here we have shifted it just in the same way as it was done over here. So once again, you see, we have got the locus line perpendicular to the axis. So this is my axis, this is my perpendicular line. And then from here, once again, 1, 2, 3, 4, 5. And then these perpendicular distances, they have been measured and this ellipse has been transferred. But again, no hidden line has been shown. So let us add the hidden line portion. Just see, hidden line portion has been added so that this figure equal to this figure equal to this figure. Only difference between second figure and the third is here the base is facing the observer, here the apex is facing the observer. So let us draw the projection. So once again, 10 points are lying onto this particular plan projection. So all 10 points, they will be drawn upwards. Just see one by one corresponding intersection points. Just like in this case, they have been evaluated. So I am showing you all these points one by one. So having located all these points, now we have to see, this is the ellipse. Please see, this is the ellipse. From here one tangent will go here, from here one tangent will go here. But let us work out which part of this ellipse will be dotted, which part of this ellipse will be dark. So please check, since the observer is going to look from this side, so this portion of the base of the cone or the boundary of the cone will be visible to the observer. Since the observer is looking at this cone as it is oriented like this portion is visible. But what are the farthest points? Farthest points are H3, A3. Just see, farthest points, they are H3, A3. So anything joining G3, H3, A3 on the interior side of the ellipse will be drawn dotted. So let me draw this. Please, again I repeat, since the observer is looking from this side, this portion will be visible to the observer. So the back portion A3 H3, where does it lie? It lies here, G3 A3 H3. So this portion of the ellipse will be dotted, that is semicircular. So let me join this. This is the second point of the axis. Now I have joined it dark initially, that is I have joined it dark without the hidden line. So then I have drawn the tangent from O dash to B3 dash and tangent from O3 dash to G3 dash. Let me make it hidden now, because I have already explained this portion will be hidden because this is farthest away from the observer. So since this portion happens to be farthest away from the observer, so the hidden lines have to be drawn here. So just see, I have done the cutting over there so that this becomes a hidden line. So please check. This semicircle is visible to the observer, this portion, whereas the interior semicircle, it is hidden part. So this is overshadowed by this external part, so which is quite apparent. This semicircle portion, it is visible to the observer, and this semicircle portion is hidden line, that is it is not visible to the observer because this will be overshadowed by this portion which is an opaque portion. So these are the projections of the oblique cone in which the axis is inclined to the horizontal plane and the vertical plane at the angles of 30 degree and the 45 degree. So we have drawn this question twice basically. You could have drawn either this portion, this would have been correct. You could have drawn this portion, even this could have been correct. But I have shown you both the solutions. So you need not draw both of these, but any one of these two solutions you can pick up. Both are equally accurate. So with this, we end this discussion regarding the projections of the oblique cone, which is having its axis inclined to both the reference planes HP and the VP. So thank you very much. Thanks a lot. Thank you.